4.4, derivatives of exponential and logarithmic functions. So we're just working out the problems. I'm gonna just blow through these because quite frankly, they're not that hard. 2 from the chain rule, e to the 2x, done. -5, e to the -5x. Yes, I could write that with e on the bottom. Why would I? E squared is not a variable. E squared. Derivative of x is 1. That just comes along for the ride. E to the x, nothing's changed there. X squared is variable, e to the x is a variable, x is a variable, e to the x is a variable. I would actually probably, let's see if this is easier. Factor out my e to the x, x squared minus 1. I think this will be easier. Y prime equals, leave it, 2x plus derivative, x squared minus 1 equals e to the x, x squared plus 2x minus 1. Sensing a mistake. Leave it, 2x, e to the x, x squared plus 2x minus 1. I have made a mistake and I cannot find where. I'll pause this, figure it out. So found my mistake. This is factor out e to the x on left of x squared minus x. Oops. So this is 2x minus 1. This is x squared minus x. This is wrong. Equals e to the x, 2x minus 1 plus x squared minus x. Yep, that looks good. Equals e to the x, x squared negative x plus x minus 1. So easy to make small mistakes. Equals 9 minus x, so this is like e to the x, but instead it's 9. So we go with dy dx equals 9 minus x times negative out front times ln of 9. Negative ln of 9, 9 to the negative x. 3 cotangent of x, that's dy dx equals 3 cotangent of x times, that's horrible. Let's just redo that. Dy dx equals 3 to the cotangent of x times, which one are we supposed to do first? I think we should do ln of 3 first, times negative cosecant squared x. Dy dx equals negative 3 ln of 3 cosecant squared x, 3 to the cotangent of x. And this one's always fun because is that x to the x squared, is it? So y prime equals 2 ln of x times 1 over x, which is 2 ln of x over x. Y prime equals 1 over 10 over x times, that's x to the negative first, so negative 10 over x squared, which is basically 10 x negative 1 over x. Let's just take a second and explore that. Two things inside can be rewritten as ln of 10 minus ln of x, and then y prime equals 0 minus 1 over x. So I leave it up to you to say which one of those is simpler. It is nice with natural logs. With any logarithm, you can actually check your work on the fly and make sure you're happy with it. dy dx. Yeah, if this is what I think it is, it's just ln of x, but we'll find out. Leave it 1 over x plus 1 times ln of x minus 1. 1 minus 1 is 0. dy dx equals ln of x. Now, natural log, if I recall, is going to be 1 over square root of x times 1 over natural log of 5 times 1 over 2 root x. And we always have to put this little, don't forget it was in a logarithm, so it has to be x is greater than 0 equals 1 over 2 ln of 5 x. And x has to be greater than 0. 1 equals 1 over log base 2 of x. I think there's probably a lot better way to do this. I can't really see it right now, so I'll just go with that. dy dx equals negative log base 2 of x times 1 over, wait a second, 1 over x times 1 over ln of 2. I guess that's it. Equals negative 1 over ln of 2x log base 2 of x squared. And let's see what we got here. dy dx equals 1 over 1 plus x ln of 3 times 1 over ln of 3 times derivative of 0. Derivative of this is just ln of 3. See ya. Equals 1 over 1 plus x. I really should have put the ln of 3 first, but that's okay. And there's going to be x has to be, let's see, x ln of 3 equals negative 1. Has to be 1 plus ln of 3 has to be greater than 0. X has to be greater than 1 over negative 1 over ln of 3. Over here, we would have at the very end, x has to be greater than 0. No, you don't have to write these in. That's just me trying to do my job properly. I guess if you're going to get into it, you'd have to say x has to be greater than 0 up here. Yeah, I'm going to do it here, and then I'm going to stop doing it. Waste of time. Does not show up on tests. They'll ask the question saying, assuming x is greater than 0, assuming x is whatever. Key dy dx equals 1 over e to the x times 1 over ln of 10 times e to the x. Seems so weird. Obviously, there's a way to simplify this with change of base equals 1 over ln of 10. Change of base would be ln of 10 over ln of e. No, that's not it. I forget how it goes. Another time. dy dx equals 1 over 10 to the x. Right, times 10 to the x times ln of 10, unless I'm mistaken. Yeah, equals 1 over, no, it's not 1 over, ln of 10. We're pointing the graphs, tangent line perpendicular to this line. Let me get some ugly decimals in here. dy dx equals 2e to the x. Perpendicular, so we want a slope. Here, the slope equals -3m. The perpendicular slope equals 1/3. Okay. So that's the slope we want. We'll put on the graph. So we found the derivative. So we want to say 2e to the x equals 1/3. E to the x equals 1/6. ln of e to the x equals ln of 1/6. X equals ln of 1/6. So that's my x value. And then to find the y value, y equals 2e to the ln of 1/6 minus 1. Yeah, they cancel. Equals 2 times 1/6 minus 1 equals 1/3 minus 1, -2/3. So the point is ln of 1/6, comma, -2/3. You look, you don't see that. You realize that, no, that's fine. Just don't forget that's ln of 1 minus ln of 6. Ln of 1 is 0, so it also is the same as ln of negative ln of 6. We'll get there. No rush at all. A line with slope m passes the origin of tangent. What's the value of m? dy dx 1 over x over 3 times 1/3. Yes. Equals 1 over x. Pass through the origin, tangent to the line, y equals x, 1/3. Now I don't know exactly what that's going to look like. It's going to be something like this. And it goes through the origin and hits somewhere. I believe we know this is going to be a comma ln of a. Sure. So slope m past the origin, it's tangent. What's the value of m? 1 over x equals ln of a minus 0, ln of a over a. This is on this line. This point is actually, that is the point A. No, that's not ln of a, it's ln of a over 3. Cool. All right. Always forget what to do at this point. Oh, we know what x is. That's why we have that point. So it's 1 over a, ln of a over 3 by ln of a over 3 equals 1. E both sides. And the slope is 1 over 3. Test question. dy dx 1 plus root 2 times x to the this minus 1 root 2. I feel like I've made a mistake. Nope, that's it. Wow, I did it wrong on my old assignment. I went implicit and all this craziness. No, it's just a variable to a number, and you just subtract 1, and yeah, you know the deal. That's funny. Y equals x to the 1 minus e. dy dx equals 1 minus e, x to the 1 minus e minus 1, negative e. That's it. Wow, I made this a lot harder in the past. That's funny. For the 4 problems below, find blah, 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 state the domain. Yeah, sure, whatever. F prime of x equals 1 over 2x plus 2 times 2 equals 1 over x plus 1. And 2x plus 2 greater than, I'll write it out, 2x plus 2 greater than 0, 2x greater than negative 2, x greater than negative 1. It's greater than negative 1. Because there's nothing wrong with this domain except x can't equal negative 1. And there we go. Here is the domain sets it. All right, 20. F prime of x equals 1 over x squared plus 1 times 2x, 2x over x squared plus 1, x equals, oops. I gotta clean it up. Oh, what a mess. Life goes on. X equals all reals. Why? Because I can plug anything in. I can plug 0 in, plug a negative number in, I'm good to go. Same thing here. Nothing's going to cause negative on the bottom. F prime of x equals 1 over root x plus 1 times 1 over ln of 10 times 1 over 2 root x plus 1. F prime of x equals 2 ln of 10 root x plus 1 times x plus 1. And x plus 1 has to be greater than 0, x has to be greater than negative 1. Alrighty. It's funny, I'm actually getting faster at my math just from practicing. Scary thought, huh? Logarithmic differentiation to, yeah, okay, whatever you say, man. I think we want to go natural log of y equals x, natural log of sine of x. Yep. 1 over y, chain rule, dy dx equals, leave it, over sine of, hello, x times cosine of x plus derivative and leave it. I dy dx for y equals 0 is less than equal to pi, sure, whatever. So, I know y is that. I'm going to multiply it up. Dy dx equals, just leave it. Sine of x to the x times x cosine of sine cotangent of x plus ln of sine of x. Kale. Spread of flu in a certain school is modeled by this logistic equation where 200 so many people are in the school. Eventually, everybody's going to get it. It's going to spread really fast in the middle, and then it's going to taper off. Initial number of students infected with the flu. So P of t, 200 over 1 plus e to the 5 minus t. P of 0 times 0, 200 over 1 plus e to the 5. I got to throw a number out here, so we're going to go with 1.339. We're going to go with approximately 1 student. Okay, now how fast is the flu spreading after 4 days? Well, that's the derivative. So we got a little work to do here. P prime of t equals, I'm going to throw this up to the top. I am not going to take the derivative yet. 200 times 1 plus e to the 5 minus t to the negative first. That's a t, not a 6. P prime of t equals negative 200, 1 plus e to the 5 minus t to the negative second times, derivative is just e to the 5 minus t times negative 1. See ya. See ya. Yep. P prime of, I'm going to combine kind of 2 steps here. 200 e to the 5 minus 4 over 1 plus e to the 5 minus 4 squared. P prime of 4 equals 39.322 students per day. I feel like I should have been able to do that without a calculator, but no, it's e to a value, yada, yada, yada. When will the flu spread at its maximum rate? Well, I happen to know this one. Oh, wait, I guess I don't. Well, it's when there's 100 people. So if I blast out a table with this, I'm going to find, we'll get to this another time. It's 100 people have been infected. So we would actually go with 100 equals this, solve for t, and then back out. And it's about when t equals 5. And you might say, well, it should be 100, this answer. No, that's 100, when 100 people infected, right? What is this? It's like a parametric. You got a lot of work you got to do here. But according to my table with this, the maximum occurs at approximately 50 students per day. All right, some good math. Good luck. Happy mathing.